All right, so we have the option, you guys have the option to use a note card on your final exam. So just one singular note card, looks like this, right? There's a single standard note card, 3x5 size. You can write whatever you want on it, any formulas, any example problems, maybe like a quote that encourages you, something like that. And you can use it on the final exam. Right on the front, back, just this one note card, and you'll be allowed to use it on your test. Maybe an example problem, something like that. So if you need a note card, like you don't already have note cards, raise your hand and I'll give you one. And keep your hand up until I give it to you. Only this size note card will be allowed. If you come tomorrow with like a bigger one, then that's too bad. Won't be able to do that. All right, the final exam is tomorrow and Thursday for you guys. All right, I will not see you on Wednesday, but that's the last 2 times that I will see you guys, and then that's it for Algebra 1-2. So, you know, make it count on anyone not get a note card that wants one. All right, so that's the last 2 times. You only have 1 day to take, not 1 day. You only have 2 class periods to take your final exam. So we'll split it between 2 days, Tuesday and Thursday for you guys. And it's 25 questions, so it really shouldn't, like, that should be plenty of time to do 25 questions. All right, any questions about that? All right, so that is coming up tomorrow and Thursday for 4th hour. Now, are there any from the packet that you would like to see worked out? The ones that you got wrong and you don't know why they're wrong, or the ones that you didn't even know where to start? I know people forgot about average rate of change. They forgot about how to factor, things like that. So what number from your packet would you like to see? Yep. 37, you said? Okay. So 37 right here. Identify the vertex for the graph. All right, your guys' final exam is going to be on Galileo. And I know you have a graphing calculator function in Galileo. That's for your final exam. But I'm not familiar with it too much. Like, I don't know if it's Desmos, but either way, you can have a graphing calculator. So what I would do for this one, so here's my equation. I'll write it bigger so you can see. Is I would graph it, and this time I'll use Desmos for it. I would graph it and look for either the highest point or the lowest point of my graph. So since this graph is going to be negative, so the leading coefficient is negative, it's going to look something like this. Whatever the highest point of my graph is going to be my vertex. All right, you could also solve for it algebraically. So you can do the formula for axis of symmetry, which is this. So negative e, what's my b value? Remember, it goes like this. My b value is 6, so plug that into this formula. And then what is my a value? Negative 3. So then my x value of my vertex is going to be negative 6 divided by negative 6, which is what? A positive 1. Good. So my x value of my vertex is going to be a positive 1. How can I find my y value algebraically? Good. I can plug in my x value, which is right here, into this equation. And I know the calculator on Galileo is user-friendly, so I know you can enter it just like this. You can put this entire right side of the equal sign into your calculator on the final exam. And when you do that, what do you get? Anyone get this one right? -1. All right, I'll take your word for it. So my y value is -1. Put it together. So my vertex is 1, -1. Questions about how we did that? All right, any other questions from the practice? Yeah, go ahead. Someone give me a question. Yes, number 2. All right, so number 2, the number of members, which is represented by f(x) in a baseball club increased by 45% every year over a period of x years. The function below shows the relationship between f and x and x. So this formula is going to be important. We need to make a table and graph the function. Anyone know like what classification this equation falls in? Like, is it linear, exponential, quadratic? It's not quadratic. Quadratic has an x squared, remember. It's not linear. Linear is y equals mx plus b. So the last option is exponential. All right. You know it's exponential because the x is the exponent this time. All right. So things like in this format. All right. Because I know it's exponential, what I'm going to do to make my table and graph it is I'm just going to make my x values -2, -1, 0, 1, and 2. I'll start there. I might have to add some more x values depending on how my graph looks, but I'll start there, kind of giving you a good idea. So if these are my x values, how can I find my y values? Good. Plug them in for x in the equation that we did. So here's my equation. Got 25 times 1.45 to the x power. If my first x value is -2, I'm going to plug that in anytime I see an x. All right, the left side of the equal sign, this part, is just notation. All right, it's not like I'm saying solve for f or something like that. You just leave the left side alone, saying that -2 is your input. Your output is what you get from putting this in your calculator. All right, and I think the one on Galileo, when you type it in, you'll have to type it in looking like this. All right, but you type that in and what do you get? $52.56. All right, so that's my first y value. And when I graph it, it'll be 2, 52.56, which doesn't fit on this graph, but you guys see like how we're making the thing. So keep going for the rest of the x values. Oh, and I forgot to put a -2, sorry. So would that change it if it's a -2? Okay, what is it? 11.89. Sorry, guys. Forgot the negative. 11.89 is what goes here. And then for the positive 2, we did enter that one was 52.56. All right, when it's negative, it's 11.89. All right, then plug in your -1. What do you get when you put this in your calculator? 17.24. All right, and then plug in 0. 25, plug in 1. 36.5. All right, and this graph here doesn't really look like it'll fit all those numbers. You can kind of up the scale if you want to, but for the multiple choice, I think you're just picking one that matches. So look for a graph that has points at the coordinates. All right, so if I was making this, probably 0 here, then count by 2s. All right, but I would have a point at 0, 25, at 1, 36.25, at 52.56. All right, I'll show you what it looks like if it does move real fast, since you do have a graphing calculator. Fine. All right, so here's how that graph looks in Desmos. I just typed it in exactly how it looked on the paper. So pick the one that matches this shape. Questions? All right, any other questions from the packet? Yes? Number 3. Okay. Number 3. The sales totals at Linda's food store have increased exponentially over the months. Which of these best shows the sales in the first 3 months? All right, so exponentially means that it increases or decreases at a really fast rate, right? So if they increase exponentially, the graph maybe looks something like this, right? Which of these best shows the sales in the first 3 months? So would it be A? Goes up about 50 each month. Would that be an exponential function? All right, I would disagree. That looks more like a linear function because it's increasing at a constant rate, right? So it's not going to be A. What about B? Do you think it would be B? So it goes up by 60. And then from this one to this one, that is up by 73. All right, let's kind of table that one. All right, what about C? Would it be C? Where it goes up by 85 and then up by, what is that? 15, up by 85 again. Would it be C? All right, why is it not C? Because it's linear, it goes up at a constant rate. What about D? How much is it going up by? So it goes up by 72, and then it goes up by, I don't know how to do math in my head. What's the difference for this month? 72 again. So it's definitely not D, because that one's also linear, right? The only correct answer would be B, because that one is not going up at a constant rate. That one fits more of the exponential part. Do you see why that makes sense? All right. Any other ones from the packet? Number 5. All right. So given the sequence a sub n equals 3n minus 1, find the 8th term. So this one, it already gives you the equation to use, and it's saying find the 8th term. So this n stands for n, like whatever term they tell you to find, you're going to plug in the 8th there. So if they want me to find the 8th term, I just plug in 8 anytime I see an n. And it looks something like this. So like this on the left side is just notation. So you're not solving for a or anything. This is just notation. On the right side, though, I can simplify the right side. What's 3 times 8? 24. And then 24 minus 1 is 23. So this right here is saying that the 8th term is 23. All right, so if it gives you the equation, just plug it into the equation. That's all you have to do. Question? Any other ones? Number 6. All right, this one had an error on your packet. I believe on the computer, it actually looks like this, where the 4 is positive. All right, sorry if that confused you. Maybe if I write it like this now, that makes more sense, right? All right. So the question is, identify the type of sequence. So for that, your options are going to be arithmetic or geometric. And then it says identify the type of sequence and then identify the pattern. So that one is either going to be, I spelled that wrong, common difference for the arithmetic or common ratio for the geometric. All right, arithmetic sequences are stuff where you it looks like you're adding or subtracting each time. Common ratio is where it looks like you're multiplying or dividing each time. So for this sequence, all right, over here the end just means like this is the first term, this is the second term, third term, whatever. This part, what's going on each time we move to a different number? We're multiplying by 5, and the 5 is negative. So we're multiplying by -5 each time. That's why the signs keep flopping, right? Or flip-flopping, whatever. So if I'm multiplying, is this a geometric or arithmetic sequence? Geometric, because we're multiplying each time. And so my common ratio, because ratio goes to geometric, is -5. Questions about this one? All right, just a side note, I don't know if this will be really that important, but you find your common ratio by taking each term and dividing it by the previous term. All right, Sloan, you had your hand up? Number 7. All right, about to scroll down. So the following table shows the number of hours some students of a class listen to music each day create a histogram. Histograms are different than most of your other graphs. All right, histograms need to have intervals down here of what numbers your data falls into. And then on the left side, it's going to be titled frequency. So how often something occurs in that range. You're not putting students down here, so I don't really even have to worry about that line for histograms. All right, down here is going to be hours, so you need to spread them into intervals. All right, so like what's the smallest data point that I have on here? 0.5, right? So if I'm coming up with my intervals, maybe my first interval could be anything from 0.5 to 1. So that's 0.5, 6, 7, 8, 9, 10. That's 6 numbers. Maybe I'll actually change that to 0.9. I like intervals of 5. So 5, 6, 7, 8, 9. And then my next interval will be stuff from 1.0 to 0.4 or 1.4, sorry. And then maybe you think that covers almost all the intervals. And how often something occurs in each interval, I would write like over here. And that's what I would make my bars go up to. So like how often do we have a data point between 0.5 and 0.9? 1, 2, 3. How often do we have something from 1.0 to 1.4? 0. How many times do we have something from 1.5 to 2.9? All right. Should be 1.9, sorry. How many times something from 1.5 to 1.9? All right, I counted 6 as well. We still need another interval because that doesn't cover all of them. So 2.0 to 2.4. Nothing, right? One more interval. 2.5 to 2.9. Have 1, 2, 3, 4, 5, 6. All right, maybe the histogram on your screen doesn't look exactly like this, but you should have even intervals, and it should go up to the frequency that it says. So maybe you could like combine these two, something like that, match it to the one that looks like on our All right, final exam is tomorrow. Be prepared, make your note card. All right, so you guys will submit your answers to that review packet that you've been working on through this puzzle piece that's on Schoology. So it is the same exact order that is your packet, the same exact question. The only difference is that it has multiple choice options, whereas your packet did not. All right, so you are going to be selecting the correct multiple choice option based on what you got when you worked on it. You had 2 class periods to work on it. You knew about it in advance. I told you exactly, like I'll be checking it Monday. This is how I'm checking it. So I want to hear your excuses. All right. You should have had it done by now. You're putting them into the multiple choice option. Hold on. The multiple choice option in Schoology on the puzzle. All right. If your answer is not there in the multiple choice options, that means that your answer was not the correct answer. So maybe you'll want to star that one so that when I go over it in about 10 minutes, we go over that one. And then you know how to do it on your slide. So I'll give you about 5 minutes to transfer your answers. If you didn't do a particular problem, it was difficult, or you didn't finish, or you didn't do it, maybe venture a guess. All right, because after 1 p.m., I am no longer updating grades. All right, I'll have some test corrections that I still need to add and things like that, like extra credit sheets that people submitted that I need to add. And then I'll add this. But after 1 p.m., I'm no longer updating grades. So if at 12:30, your highest score on this puzzle piece is a 10 out of 20, but then like at 1:30, you get a 20 out of 20, is going to stay a 10 out of 10. Does that make sense? Yeah. All right, so you have a limited number of attempts on this puzzle piece. Put your answers in, see which ones you got wrong, maybe star them so that we can go over it. So that you can rework it and put in the right answer and submit it again. Any questions on this? Did I answer your question? I won't be checking your work on the packet. I can tell by how well you do on this puzzle piece who worked on it and who didn't. All right, because if you worked on it, you have a lot of it right. That makes sense. And you have a limited number of times, at least in one. Any other questions? All right, so do that. Give you 5 minutes just to put in all your answers, see which ones you got wrong and right. And then we will talk about one other thing and then go over the ones that you have questions on. And the reason this is brand new, that I didn't tell you about it sooner, is because I found out the other Algebra 1 2 teachers are letting their students use note cards on the final. So I didn't want them to have an advantage that you guys didn't also have. So you guys will be allowed to use a single note card. All right, this shape, it is a regular 3 by 5 inch note card. You can write on the front, you can write on the back, you can write formulas, maybe an example problem, maybe like motivational sentences for you, but you will be allowed to use it on the final exam. Only one. All right, it has to be this size or you can't use it. I do have some if you need one. You don't have to buy a whole pack of note cards just for one note card, but that is what you can use if you choose to take time and write something on it. Raise your hand if you would like one, if you haven't tried one. Anyone else? Yes.
Yeah.
Anyone else want one that I did not give one to? All right, so that is your little advantage for you for your final exam. Do take advantage of it, write whatever you want in formulas, example problems, and have it ready for tomorrow. So tomorrow's day 1 is your final exam. Like I said, it's only 25 questions for both days, if that makes sense. So there's 25 questions total. You'll start it tomorrow. And then for you guys, my 5th hour, we'll finish it on Thursday. I will not see you on Wednesday. Questions? All right, any questions from your packet that you'd like to go over? Yes?
The second one.
The second one. All right. Oh, you're okay. So here we are. All right, so the number of members in a baseball club increased by 45% every year over a period of X years. The function below shows the relationship between f of x and x. So the relationship between your output and your input. This equation right there, and I know it's already written, but it's an exponential type of function. All right, the other two that we learned were linear and quadratic. So like linear functions, what do those look like? Y equals mx plus b. So if you have a function that is linear, and I'll just kind of write this off to the side. So it looks like that, or this, where it increases or decreases at a constant rate. that will be in the format of y equals mx plus b. If it looks like a quadratic, so like that or like this, that one has a formula that has what in it? Yes. It'll be something in this format, or it can just be like the x squared. It'll have an x squared. All right, the other type we learned is something that looks like this, where it's like the exponent is the x itself, right? So that's where it's your exponential function. So when I see an equation that looks like this, I should know that it's either looking like this, where it's like increasing at a really fast rate, or decreasing at a really fast rate. So I put some points here. Since it's exponential, we usually started with like the points from -2 to +2. But you can add more, like probably more to graph this one. But you start with your x's being from -2 to +2. How do you find your y values? Oh, you put the x in. Good. Exactly. You plug in your x values into the given equation. So here's an example of when we plugged in like -2 and -1. Right? Here's my original equation. Anytime there's an x, I'm plugging in the x value, right? And then we're putting what I circled over here in red into Desmos or your calculator. So like your calculator on your test, I don't know if it's Desmos, but I do know it's a graphic calculator. And I do know that it is user-friendly. So you might have to type it in like this with the little like caret thing, right? But that's how you type it in. And when you do that, you get 11.89. All right, then you plug in -1. Put that in your calculator. You get 17.24. And then you keep going until you have enough points to graph it. Questions about that? Now this graph here, I would have to, label it so that it includes these points. So I might have to get like a little creative there. But, if you have a graphing calculator on your test, you can just type it in. And I'll show you what that looks like on Desmos. So you type in the equation exactly how it looks. So f of x equals, yep. Exactly how it looks, and you see that it looks something like this. All right, so it has a lot of negative values. You probably need more negative values than positive values. So something along these lines is how your graph looks. Questions about that? Then did you finish answering all those answers? Okay. Any other questions from the packet? Yes, Michaela? Number 24. All right, so 24. That's a fog and box type question. So it's been a while, but whatever number is like inside of your function, so this is like a function inside another function. So it's not fog and box, it's h of j, right? We have h of j. Whatever is on the inside of your function is going to be plugged into the outside function. All right, so it says that the j function is -4x, right? It says it right here. And it says that the h function is x minus 1. So I'm taking my j function, which is -4x, and I'm plugging it into x of my h function, right? Taking it, plugging it in for x. When you do that, it looks something like this. I put in parentheses because I plugged it in. It's -4x minus 1. All right, questions on that part? How you made your new function? Right, so it's always the inside function or like the last letter into the first letter. All right, now that I've made my new function, then I can plug in the number. So it said solve for h of k of 5. So I'm going to plug in 5 for the x. So now it's -4 times 5 minus 1. -4 times 5 is -20. Minus 1 is -21. So the final answer for this one is -21. Questions on math process? So if it was C of m, right? What goes into what? Does the C go into m or does the m go into C? C goes into m. So always the last one going into the first one. All right, so something like this. Questions about this one? Questions about any others from the pocket? Yes? 23. All right. So the length of a rectangle is represented by this function. The width of the same rectangle is represented by this other function. Write an expression for the area of the rectangle in terms of x. So if we're talking about area, what's the formula for area? Good, row base times height, right? So area equals length times width. Also, I'm not giving you like a single formula. So if you don't know the formula for area, write it on. All right. Area is length times width. It says my length is 5x. So area, my length is 5x. And my width is 2x squared minus 4x plus 13. All right, length times width. So we're basically just multiplying these together. And you're not going to get a single number because there's not enough information for that. You're just going to get an expression if you multiply the 5x by this polynomial or trinomial. So distribute that 5x to each term in the next set of parentheses. So it's 5x times 2x squared. 10x to what power? Good, it is the third power. When you're multiplying with the same base, you add the exponents. So 1 plus 2 is 3. All right, 10x cubed. What about 5x times -4x? -20x squared, good. And then 5x times 13. 65x. Right? The x doesn't go away. All right, can I simplify this anymore? Are there any like terms that I can combine? There aren't any like terms, right? They have different exponents, so I can't combine them. This is the simplest it can be. I don't know what your multiple choice options are, but pick the one that says maybe f of x and then this expression. All right, so you're just multiplying because that's what it's here. It's length times width. Questions about this one? Any other ones from the packet? Yes? Did you say 33? All right. So we have a food packet is dropped from a helicopter and is modeled by this function. The graph below shows the height and heat. The food packet at different, of the food packet at different times. What is the domain based on the context? Okay, out of all the things we learned, is this linear, exponential, or quadratic? It's a quadratic function, right? Because it has that nice U shape to it. What is the domain of all quadratic functions? All real numbers, always. All right, so the domain for this quadratic function is all real numbers. Range depends on, like where your highest or lowest point is of the graph. Range would be different. It would be either y greater than or equal to or y less than or equal to some number. All right, so it's whatever the y value is of your highest point. But your domain is going to be all real numbers always. Yes. All right, any other questions from the packet? Yes? Should be all real numbers. Is that an option on your screen? Okay. All right, any other questions on the packet? Yeah. 39. All right, so 39, the function, this shows the relationship between the vertical distance of the diver from a pool of surface in feet and the horizontal distance of the diver from the diving board. What is a zero of f of x and what does it represent? So when it's asking for a zero, what is it asking for? There's other names for it. What are other names of zeros? Not rate. So here's a hint. This is a quadratic function, right? The graph looks like this or like this. We said that solutions to them. It's where they touch what axis. So if you want to remember them as x-intercepts, maybe that'll be the most helpful since it tells you where it crosses the x-axis. But other names for them are like roots, solution, zeros. All right, they might use either one of these names on your test. You have to be familiar with all of them. So what I would do for this one, and you do have a graphing calculator on your final. I don't really know what it looks like. I think it looks like decimals, I'm not sure. But I would graph this, and then I would look for where this parabola, and it'll be negative, so it'll look more like this one, where it touches the x-axis. All right, wherever it touches the x-axis are my zeros. You can also solve for it algebraically. You'll have to, if you want to solve for it algebraically, because maybe you won't know how to use the calculator tomorrow, you set it equal to 0. For this one, you can factor it or use quadratic formula, but again, I'm not going to use the quadratic formula. So you have to write that down on your card. If I solve this one by factoring, what are two numbers that multiply to 10 that add to -9? And which one has to be negative? 10. Good. It has to be the 10. Because that's how you get it to add to the negative. Then we get x minus 10 times x plus 1. Set each one of these factors equal to 0 and solve for x. So what is my first x value? X equals 10. And then this x would be -1. So these are my two zeros for this function. You can graph it using quadratic formula or factor. Questions on this one? All right, one more question. Who would like to ask it? 43? Oh, yeah. Yes, please. Okay, let's see. Okay, sorry. So 43, we have mirror and frame that have an area of 15 square feet. The mirror is 3 feet wide and 4 feet long. What's the quadratic equation that can be used to determine the thickness So the area has to be 15, and we know that area is length times width. What's the area of this inside rectangle? All right, the area of the inside rectangle is 12, but we know that the area for the whole thing is 15. So let me speak for a second. I don't know if it was time. I'll record it if you guys, if the bell rings. You watch it at the end of the video. It's on the back table. All right. So we have. Honestly, I don't know. That's not by the time. So I'll pause and then I'll record it and upload it and you can watch it then. All right, so here's the one that we ran out of time for in class, number 43. So what is going on here is that this diagram represents a mirror and a frame around it. So here's the inside mirror, here's the frame around it. I think that these X's here are kind of confusing because at first I wasn't sure what they were labeling, but they're actually labeling like the length and width of the frame, right? So they're saying that the frame, like this distance to this distance is X, and then right here, this distance to this distance is also X. So what is actually going on is like that this down here, the width of the whole thing is going to be X plus X plus 4. So really it's 2X plus 4. And then this over here, the length is X plus X plus 3. So really it's 2X plus 3. So here's my length, here's my width. We plug that into our formula for area. So it's 2X plus 3 times 2X plus 4 equal to the area, which is 15. All right, to multiply these out, we are going to FOIL them or distribute. So I'll do the arrows for distributing. All right, but we have 2X times 2X, which is 4X squared. 2X times 4 is 8X. Then we have 3 times 2X, which is 6X. And 3 times 4, which is 12. All right, then equal to 15. All right, I'm gonna move the 15 first before I combine the like terms, because that's what we usually do to solve quadratics. So I'm gonna move the 15, set it equal to 0, and then we have to combine like terms. So I have 4X squared, combine these like terms, so 6X plus 8X is 14X, and then 12 plus negative 15 is negative 3. And this right here matches one of the answer choices. All right, so again, just to kind of review, it's basically 4 plus X plus X. And then over here, it's 3 plus X plus X. Simplify it, multiply them together because it's length times width. Gives us the area is 15. You know, FOIL this, move the 15 over, you get in this expression that looks like this, which matches one of your answer options. All right, study for your final, which is tomorrow, and make your note card, and I'll see you guys tomorrow.